Today 3D printing has a potential in every aspect of manufacturing, and this is a unique initiative and which I feel would help each and every seeker in this domain to further his interest and grow the technology.
It is going to bring about a revolution. You can think that a world without a disease, without disability.
Today I can say that whatever that you can imagine can be actually put into practice with the medium of a software to print or give substance to your ideas with the help of 3D technology.
It's been our conscious effort in terms of want to communicate and create the awareness.
Help us innovate faster and better, and it's easy for people to access it and make interesting products out and take their imaginations into reality.
This is a platform where we can promote these technologies
For a simple reason, because 3D printing is a technology which is going to change the way things are.
Ladies and gentlemen, a very good afternoon to you all, and it's been a wonderful afternoon, and it's a privilege and an honor to also invite some key respondents and experts in 3D technology that we have been able to connect for many years. 3D Graphy News is a platform for an information source for 3D technology across various different specializations. 3D technology will include 3D scanning, 3D visualization, simulation, 3D printers, scanning solutions, also to look at various different materials that is actually going into this. So it's an entire ecosystem in terms of all of these aspects to be known for the end users, to be updated, for them to see how they can use this in their course of business and solutions in the offering. So the technology is also gaining a lot of penetration in dental, medical, aerospace, defense, in terms of seeing that how customized manufacturing can be a game changer. And we know that unlike subtractive manufacturing, additive manufacturing is also taking a lot of scope in terms of also pathway. Now that we know that the government has also initiated the national strategy on additive manufacturing, the Ministry of Information, Electronics and Information Technology. So I think the times are good, and we are in a very exciting time. And also to then have one more key respondent in Bharat Fritz Wiener as a company, M2 Next, who is also now introduced their DD machine. So let me take the opportunity to introduce Mr. Ashok Varma, who is the Executive Vice President and Global Leader Additive Manufacturing. Mr. Ashok is a serial entrepreneur and widely recognized, and has a great knowledge when it comes to additive manufacturing, especially in metal. And he's been working in this space for the last 2004 is where he started, and also his specialization in terms of offering solutions in oil and gas, aerospace, and defense. And he's been also extensively working on real-time monitoring on CNC machines and advanced technology, and with a rich background that he also has in business management. And he is an alumni of the Indian Institute of Technology, Kanpur, and also and University of Wisconsin, Medicine, USA. So, a very good afternoon, Mr. Ashok, for your time and presence. May I quickly ask you, how did it all start when it comes to a technology like DD in terms of, and where is the gap that you see in terms of the offering?
Well, first of all, thank you very much for your kind introduction, and also all the positive things that you are doing 3D Graphy News for 3D printing for India. It's very encouraging. Okay. So 3D printing is not or additive manufacturing / 3D printing is not a new technology. That has been around now maybe 35 years now. It started, of course, with plastics and polymers with Dr. Charles Hull, and for the longest time, it was only for prototyping. Then the metal printing started slow but surely, maybe 20 years ago. Okay, and EOS in Germany was one of the pioneers for the smaller format of metal printing, which is also the more accurate format, to be honest. Slowest, most accurate, and smaller format. But they started that, it's been some time, 12, 14 years ago. Then metal printing came of age. So people realized that plastics and polymers is one thing, but metals and exotic materials and big parts and large parts and heavy parts, that is a different game altogether. Requires higher laser powers, bigger platforms, much more complex software. And gave rise to the directed energy deposition segment of metal additive, which you call DED is the short form, and Wohler's report also calls it DED. And that is a somewhat different process than powder bed fusion, that or you call it DMLS also, and SLM also. It's a very small overlap. So the powder bed fusion platforms really are for very high precision but smaller parts. Parts that typically are less than, I would say, 1 cubic foot, maybe 2 cubic feet, typically. And those processes run fairly slow but very accurately. I have to say, extremely accurate internal channels and everything, but they run slower, like 100 grams an hour, 200 grams an hour of deposition rate. Okay. Now, directed energy deposition, I was involved in this technology after I exited my previous startup, which was in machine health monitoring worldwide. And that was a very successful 17-year run. And then we sold the company and I looked for something else to do. And I got inducted as the president of the first or the second company in directed energy deposition in the world. This was a precision optical manufacturing, which is now called DM3D. It is in Detroit. And I ran the company for almost 2 years. And it was just very initial stages of DED at that time. But at that time, I learned that this is going to be the technology that I want to follow because it was based on CNC machines and high performance CNC machines and high rates of deposition of powder and multi-material deposition. And part sizes are not limited, just depends on the size of machine you make. So that got my attention and also my interest, and I stuck with that now for 18 years. So I'm one of the pioneers in this. A lot of development was done at DM3D, POM. And then I exited and became a global reseller for POM and for Optomec Lens, which is also a leading DED company at this time in US. Both are American companies. And I became more or less the largest buyer and reseller, and most of my business was done in Russia and in US. And I saw the whole technology evolve. And I stayed to be a reseller with DED in electron beam, very large chambers, 1,000 cubic feet and things like that with electron beam with the company called Sayaki. And also at that time, the largest argon-based chamber in DED back in 2014, 15, and 16, the company is RPM Innovations. Both fantastic machines, fantastic technologies, very US oriented, and I would say 20% export. So I learned everything I had to learn about DED from these two companies, and I got a lot of ideas. I have worked with all the other DED manufacturers, Trump, Beam, Instec, around the world. I've either sold their machine or used their machines in different applications because I became a service provider for 5 years for oil and gas and aerospace and defense and tooling, die and mold. So I became really deep into the DED segment. Then I moved to Dubai from US after 36 years in US, and I consulted with the crown prince there. But they wanted to do construction 3D printing, so I got out of that fairly quickly. I'm not into concrete. I mean, it's a great technology, but it is not my forte, so I got out of it. And then I moved to India. So after 38 years total out of India, I decided that this is time to give back to the country. And I had already been engaged with a lot of very top level people in India since about 2012, introducing DED technologies to India. But I had no takers, just a couple of small machines. And I worked with ISRO, BHEL, DRDO, HAL, and all these people. There was no private companies working in DED at that time, so all were PSUs actually. Then I moved in 2017 to India, and I engaged with Reliance Industries with the chairman's office to create some large-scale 3D printing service bureaus for Reliance. And eventually the project was not executed because Reliance had a different strategy, rightly so, for retail and telecom in India. And they are doing service to the Janta actually. And 3D printing dropped off the list of interest. So I became an independent consultant. And I consulted for pretty much every service bureau in India. And as a free service to all the large PSUs in India to introduce them to the large format metal 3D printing, which is also called DED, Directed Energy Deposition. One thing led to another, and just 7 months ago, Bharat Fritz Werner, which is the leading machine tool company, CNC machine company and Industry 4.0 company in India, I've known their CEO director for years. They discovered that I'm living in India. They always thought I'm living in US, which I was, but in 2017-18, I was in India. And they said, we want to get into the DED space in a big way and in a hurry. And we have looked around, and you seem to be the right person to lead us into this whole space. I met them and concluded an agreement, and I started with them in September of last year, 2021. And wasted no time. They are willing to invest. They're very innovative, very aggressive with this, and they have a vision which matches my vision. So our joint vision is very strong. And our vision is, of course, to be the leading DED machines provider and solutions provider in India and Asia, and jump straight into the Western world, EU and US. And given that I know pretty much the entire industry over 15, 16 years, I know everyone and all the technologies, it was a pretty straightforward step to take. And I asked for a certain budget, and they did not hesitate. It's a significant budget. Did not hesitate. And therefore, you see the press releases and the advertisements that are going to be coming out at Rapid and at Formnext and in all the leading international magazines and also the Indian ones during the summer and autumn for what we have designed easily as, first of all, the largest DED printer, second of all, the largest argon chamber-based DED printer, third of all, the only DED printer that provides independent gantry-based solutions for powder deposition and wire deposition, fourth, the highest power laser in any DED machine as a standard feature. And fifth, of course, the price points being somewhere between 30 and 50% of anyone in the world, with the specifications at least twice the size and twice the performance capability. So a 4x benefit to India, made in India, 4x benefit over the Western and the Asian markets who have been in the DED field 15 years before India. We are basically going to disrupt and lead the pack by December, when our first, what the media is calling the giant 3D printer will be released. We are starting to build it as of this month. It will take 7 months to build it. We'll release it in December and have a very big open house for it. And this machine, we are clear about it. We want to provide the best solutions to the Indian industry first. And of course, the space technology and the Ministry of Defense will be your largest initial adopters, along with some private industries. I'm very bullish about companies like Larsen Toubro, Adani, and Reliance, and other such companies getting into this once the machine is available. But we'll be serving the government initially. And we all know that the government projects are very lucrative, but this takes some time. So we are going to fill in the gap and introduce a full range of DED machines in the argon chamber and on robots and in CNC machines that BFW manufactures, which offer the 3D printing and CNC machining in the same chamber. So we call it hybrid. The industry call it a hybrid 3D printing metal machine. So we are going to fill out and flesh out the product line with machines that are going to be 1/2 the size and 1/4 the size of this giant machine we are introducing in December. We also have a vision which will easily be the first in India and very few in the world to put laser heads on mobile robots so that the 3D printer can go to the part for repair and reconditioning of parts such as Navy parts, marine parts, large construction tooling and things like that, where the part cannot come to the machine because the part weighs 30 tons, or it's a submarine. I mean, it cannot come to the machine. So we are devising a mobile system to go to the part. So end to end, our vision is, and our expectation or hope or our ambition is to be the largest metal DED 3D printing company in the global industry within 2, maximum 3 years. And I am honored to be leading the charge and gratified that BFW has put huge amounts of confidence in me, and also really honored that I can serve India at the same time. India gave me a lot with my IIT Kanpur education and all of that. I mean, that education will cost me $500,000 in US easily. And I just want to give back to India in my, what I call my 4th stage of my career. And I'm very excited, very bullish, very motivated, and glad to be talking to you about this.
Thank you so much, Ashok. I think you didn't allow me to ask questions. You've been very, very candid in terms of sharing each and every aspects one by one. So thank you so much. I think very proud of an initiative like this, Ashok. If I may ask you, if there is an immediate requirement for this machine, where do you think that we can fill the gap? In which industry, as in which sector?
Immediate requirement, space technology, and defense technology,
Okay.
and specifically ISRO and DRDL,
Okay.
both the propulsion companies, for sending things into space or missiles into the space also, for printing fuel tanks, bodies of the rockets and missiles, the nose cones, and the exhaust nozzles. And I will send you some examples you can use in the edit of the video of what NASA has done already, and we will match and beat those parts within a year and a half in India. And we intend to export such parts to non-sensitive industries, because there are limitations on what we can send from India, and there are limitations by Lockheed Martin and NASA and US Ministry of Defense. But everyone already has reacted, the big players, to the press release we made a week ago, and said, Ashok, when is this machine available? Because we are enchanted by the possibilities and the price points. I mean, see, it's fundamental. The more expensive the machine, the more it costs to print the part. Let's face it, because it's an amortization per hour. So I agonized over designing the right machine at the right price point at the right cost, where BFW doesn't lose money, that we make a decent standard profit, and the industry can jump into it and say, now we have a solution where we can make a part that is 2.5 meters tall by 2 meters in diameter in titanium at less than half the cost of what we were printing this with other machines in the past. It's a game changer.
Fantastic.
It is truly a game changer, and India will change the game. I have always been confident that when India starts to rock and roll, it will rock the market, and this is how we are going to do it. We are not going to dump product. We're not going to sell it under cost. We have found the engineering skills, and BFW has some of the best design engineers for machines. We have found the right laser partners, laser delivery partners, chamber manufacturing partners. All of these we have already found, and we have created a platform which I believe will be incomparable, and we will lead the pack, and we will sustain that.
Okay. So one more thing that I would like to understand is, Ashok, now that we've already got the plan set and ready, and just time for it to start, we see the machine. Is there an affiliation that you also have with certain ministries in terms of wanting to come out with IPs or products very related to a certain industry, as in very specific to aerospace or any other space, as you mentioned? Is there an IP in terms
intellectual
of
property?
Yeah, intellectual property.
Well, the intellectual property in metal 3D printing is very straightforward. It is the recipes, the process with which you print the part. That is fundamentally the IP. The laser is not the IP. The machine chamber is not the IP. The gantry systems are not the IP. The tilt, rotate, even 7-axis manipulation is not IP, because all the CNC machines have already been doing that. The IP is the art of making the part, large parts, thin wall parts, complicated parts, right the first time. That is the IP. And we will work with the all our customers, users, let's call it, and print parts for them under contract, or have them purchase machines and help them get up and running. Maybe even do boot concepts, because these large machines may not be in the budget for even medium-sized companies initially, $2 million, $2.5 million. So we can start by making parts for them under contract. And when they are fully confident with these platforms, they will buy the machine, because then they'll save more and more money and they'll be fully trained. And we will share, we will do joint technology, simultaneous engineering, and IP development jointly. We will do joint ventures with companies, and we will do boot with companies, and we will sell machines to companies, whether it's in US, or in Europe, or in India, or in Singapore, or in Middle East, or in Australia. We are going to do a global initiative and a global rollout over the next 6 to 7 months.
Fantastic. Ashok, thank you so much for your detailed interview. I think you have covered almost every aspect of this business and the prospect that it can give to the country when it comes to manufacturing with additive, because we are looking at beyond the scope when it comes to large parts and large printed metal parts. It was always a challenge, but I think DED can give that particular. I mean, you have a solution here. Anything that you would probably want to also
Let me share a couple more things.
Yeah.
This is regarding the global industry trend, because as I said, I have been a global player and a global thinker since I've been 28 years old. And all my 4 startups previous were all global. They were not US centric or India centric or anything. It's just global. Okay. And the trend that the analysts are indicating, including, I won't take the names because they will be publishing their own reports. The next decade will be the decade of large metal parts at lower cost and faster speeds. The powder bed fusion will continue to grow at its 20 or 30% a year, but the DED segment could grow at 100% a year for the next 5 years. Because that has been an unmet need. Around the world, the DED machines have been very expensive, and rightly so. They involve very high powered lasers, big chambers, a lot of mechanics and mechanicals and all of that. But all of that is being pulled back. And proper engineering or better engineering or more economical engineering is being done to make it affordable, certainly to the large users and also to the mid-size users. For the small, the SMEs and all, the small DED machines will introduce in the price range of 2 crores. They will be accessible to SMEs, but of course, their part size will be smaller and the speeds will be lower. But again, you get what you pay for. I mean, if you pay for a Volkswagen, you're not going to get a Bugatti or a Ferrari. Let's face it, okay? So we're introducing the full line from the Rolls-Royce, Bentley, Bugatti, Ferrari, Lamborghini, all the way down to the Maruti and the Volkswagen and the Hyundai of the product line. We want to fill and serve the entire market step by step. Of course, we are not a multi-billion-dollar company. We cannot do it all overnight. But over the year, 12 to 15 months, we will have a fully fleshed out product line. And we will play the game the right way, honestly, ethically, and economically across the globe. And believe me, India will come rapidly onto the global map for metal 3D printing. We are going to engender that change, and the pride of Make in India will make everyone proud. Okay?
Interesting.
That's what I had to say.
Now that you mentioned about this, so democratization is going to be the key, Ashok, that we are looking at.
Yes, and that is fundamental. You can't just have a $3 million machine. You'll sell 4 of them in 2 years. You want to have 7 machines that range from 200,000 to 3 million, then you sell 40. Okay? And that is the way the industry starts to use this. I mean, I see, to be honest, to be clear, the biggest application field I see in India initially, besides the very ultimate premium applications, is the repairing of the die and mold industry, forging dies, cutting tools, stamping dies, injection molding dies. That is a massive area which powder bed fusion cannot address. Powder bed fusion can print parts. It really cannot repair parts. There are very advanced technologies for that Siemens has developed and GE has developed, but that is ultra expensive for powder bed fusion. I'm talking about a machine that is in 2 or 3 crore region that can repair and refurbish tooling dies in India. At least half of the entire market of tooling dies we can address for the SMEs and the tooling manufacturers. And that is going to be a very large area. Then you reduce your dependency on importing tooling and dies from, say, Asian countries, China, Taiwan, Korea, and all that. And you can just repair and recondition the dies you have bought overseas, for example, on the ground in India at 10% or 5% of the original cost of the die and put it back in service right away. that is going to be a major boost to the productivity and the cost competitiveness of the Indian tool and die industry also. And we look forward to participating and helping that. Okay?
Good. Thank you so much, Ashok. I think repair is a great area that can be filled in when it comes to solution.
Only with DED, boss. Only with DED.
Is the only solution. Very true.
Yeah.
Thank you so much, Ashok, for your time and wishing you all the best. And we are all waiting for the machine to get live and seen. I would be the first person to probably want to come.
We will invite you. We'll have a huge open house, and you will be one of the first invitations.
Right. Also, Ashok, we'll also want to connect with all the end users on a day and time. We'll also want to invite them to also, ask their relevant questions to be addressed eventually. So, because this is an interactive platform that we are building with time.
Sure.
More than an event, it is also to see and address all these points. So, thank you so much. I think most of the inputs are already been covered. Thank you so much, Ashok, and wishing you all the best. And we'll keep in touch. And all the very best for your endeavor.
Thank you so much for having me, and we stay in touch. I'll send you some information tonight. Okay.
Thank you so much. Thank you so much.
Have a good one. Bye.
You too. Bye bye.